One of the biggest problems with automating content creation, especially video scripts, is consistency. I can get Claude to generate a script for a YouTube video, but sometimes the output is just not good enough. It might miss key points, or the tone might be off, or it might just be too short. Relying on manual review for every single script defeats the purpose of automation. My goal with autopilot dev is to build systems that run themselves, and manual review was a bottleneck that I absolutely needed to eliminate. This isn't about avoiding work. It's about making sure that what goes into the next stage of the pipeline is actually usable without human intervention, which significantly reduces the cost and time of the subsequent steps, like video editing and voiceover generation. I needed a way for the LLM itself to determine if its output met my quality standards, and if not, to try again. This became the foundation for what I call the Claude Quality Gate. The core idea behind the Quality Gate is a feedback loop. After Claude generates an initial video script, I don't just accept it. Instead, I immediately feed that script back to Claude, along with a specific prompt designed to act as a quality reviewer. This reviewer prompt asks Claude to evaluate its own previous output against a set of predefined criteria. These criteria are critical. For a video script, I'm looking for things like: is the introduction engaging? Does it clearly state the problem and solution? Is there enough technical detail? Is the tone consistent with my channel? Does it flow well from scene to scene? And most importantly, is it long enough to be a viable video? Each of these criteria is weighted, and Claude is instructed to provide a numerical score from 1 to 10 for each, and then an overall score, along with a brief explanation for its judgment. This structured feedback is what allows the system to make an informed decision. My implementation uses a Python function, let's call it assessScriptQuality, which takes the generated script as input. Inside this function, I construct the evaluation message for the Claude API. The prompt is carefully engineered to elicit not just a score, but also actionable feedback. For instance, I might include a line like, if the score is below 7, explicitly state why and suggest concrete improvements. This is crucial because if the script fails, I need to know how to guide the next generation attempt. The function then makes an API call to anthropic.messages.create, passing the evaluation prompt and the initial script. I parse Claude's response, extracting the overall quality score and any improvement suggestions. If the score is below a certain threshold, say 7 out of 10, the function returns false along with the feedback. Otherwise, it returns true. The retry mechanism is a simple while loop. My main script generation function, let's call it generate video script, now includes this loop. It starts by calling Claude to generate an initial script. Then, it immediately calls assessScriptQuality with that script. If assessScriptQuality returns false, the loop continues. Before the next iteration, I append the feedback from the failed assessment to the original script generation prompt. This is the key. I tell Claude, the previous script was rated X because of Y. Please try again, specifically addressing these points. This isn't just a blind retry. It's an informed, iterative refinement. I also implement a maximum number of retries, typically 3 to 5, to prevent infinite loops and manage API costs. If after 3 attempts, Claude still can't produce a passing script, I log the failure and move on, signaling that the initial idea might be too difficult for the current prompt or model to handle adequately. One of the most important aspects of this iterative refinement is how I handle the context for the retries. When Claude retries, it needs to remember not just the original prompt, but also its previous attempt and the specific feedback it received. This is done by structuring the messages array in the Anthropic API call. For the first generation, it's just the initial prompt. If it fails, the next call includes the original prompt, Claude's previous script, and then my evaluation feedback as a new user message, instructing it on how to improve. This builds a conversational history, allowing Claude to learn from its mistakes and refine its output incrementally. This is far more effective than just starting over with a slightly modified prompt each time, as it leverages the model's ability to maintain context over turns. It genuinely feels like I'm giving feedback to a junior writer, and they're incorporating it into their next draft. The benefits of this system are immediate and substantial. First, the quality of the scripts entering my video production pipeline has dramatically increased. I no longer have to manually review and discard or heavily edit half-baked scripts. This saves me a significant amount of time, which is the whole point of automation. Second, it reduces downstream costs. A poorly written script requires more editing time, more voiceover retakes, and potentially more revisions at later stages. By catching and correcting issues at the script generation stage, I'm preventing a ripple effect of inefficiency. Third, it provides valuable insights into my initial prompting. If Claude consistently fails to meet the quality threshold even after multiple retries for a specific type of video, it tells me that my initial prompt for that content might be flawed, or perhaps the complexity is too high for the current model. From a cost perspective, there's an obvious increase in API calls because I'm making at least 2 calls per script, 1 generation, 1 evaluation, and potentially more with retries. However, I've found this to be a net positive. Let's say a script costs $0.50 to generate and $0.20 to evaluate. If it fails once and retries, that's $0.50 plus $0.20 plus $0.50 plus $0.20 equals $1.40 for a successful script. Compare that to spending an hour of my own time, or even paying a freelancer to fix a bad script generated for $0.50. The value proposition is clear. The LLM's thought process of evaluating and correcting itself is far cheaper and faster than human intervention. I also cap the total number of retries, as I mentioned, to prevent runaway costs on particularly difficult or poorly conceptualized tasks. This ensures I only pay for a reasonable number of attempts before cutting losses. This Claude Quality Gate has been a game changer for my video production pipeline. It's transformed what was once a brittle, manual process into a much more robust, self-correcting system. It's a real-world example of applying an LLM not just for generation, but also for metacognition, making it think about its own thinking, and then act on those thoughts. This pattern of using an LLM to evaluate another LLM's output, and then feeding that evaluation back as corrective action, is something I'm applying to other areas of my automation as well, from generating social media posts to drafting blog articles. It's a powerful way to ensure consistent quality in an automated workflow. If you're building automated content pipelines, I highly recommend implementing a similar quality gate. It saved me countless hours and significantly improved the reliability of my systems. In an upcoming video, I'll break down the full Python code for this quality gate and show you exactly how it integrates into the broader YouTube automation project.